Um, you know how right before a massive storm hits, you see the meteorologists standing in front of those giant red and purple radar maps predicting
Yeah.
just total devastation?
Right, yeah. The theoretical models that show the absolute worst case scenario, like total inundation of the coast.
Exactly. You see that massive color blob on the screen. You're like, okay, time to board up the windows, stockpile bottled water, uh, brace yourself, and then the storm passes.
And you get a light drizzle.
Right. Puddle in the driveway. The model predicted chaos, and reality delivered, a minor inconvenience.
It's that classic disconnect between a theoretical computer model that's simulating perfect conditions and the messy, friction-filled reality on the ground.
Yeah, and that specific disconnect is exactly what we're looking at today. But instead of the weather, we're talking about your career. Welcome to today's deep dive. Because whether you are a lawyer, a software engineer, or, I don't know, a landscape architect, you have absolutely wondered recently if artificial intelligence is coming for your job.
Oh, everyone is thinking about it.
Right, so our mission today is to cut through the massive hype surrounding AI in the workplace and just look at the hard, cold data.
And we are working off a single, incredibly revealing source today. It's a visual data set titled Theoretical Capability and Observed Usage by Occupational Category.
Okay, so for you listening, try to picture a standard radar chart or
Right.
a spider web chart. It maps out every major occupational category around a circle. The center represents zero AI penetration, and the very outer edge represents a theoretical maximum of 1.0 or like 100% coverage.
Yeah, and we're going to look at two distinct shapes layered on top of this chart. So the first shape maps what the underlying technology is supposedly capable of doing right now, and the second maps what businesses are actually doing with it.
Right. So let's start with a theory. On this chart, theoretical capability is represented by this massive, jagged blue polygon. I mean, it practically eclipses the entire right and top sides of the circle.
It really does. It's huge.
And the tip of this blue shape points dead at Office and Admin and stretches out to almost 1.0. But wait, let me just stop there and push back.
Sure.
Because a 1.0 for Office and Admin implies AI can currently do 100% of the job. And that just feels completely disconnected from reality. Like a chatbot can't handle an angry client in person or physically fix a jammed copier or, navigate office politics to get a vendor invoice pushed through.
No, you're right. That skepticism is entirely justified, and it kind of forces us to define what the researchers actually mean by theoretical capability, because the chart isn't claiming an AI agent can put on a suit, sit at a reception desk, and just be an office administrator.
Okay, then what is it claiming?
It's mapping capability based on task decomposition. So if you break an office admin's job down into its micro components like routing emails, scheduling calendar blocks, extracting data from some unstructured PDF and pasting it into a structured spreadsheet, algorithms currently exist that can perform those isolated tasks perfectly.
Perfectly, but in a sterile digital environment.
Exactly, in a lab, basically.
So it's really measuring the raw capacity of the underlying software to process information, not its ability to actually hold down a job in a real-world office.
Right. We're talking about the mechanics of autonomous agent workflows and predictive modeling. Because when you look at the other categories sharing that massive blue footprint, things like computer and math, business and finance, legal, and management, these are roles fundamentally defined by taking unstructured data, applying a set of learned rules, and generating a structured output.
Which is exactly what large language models and, advanced machine learning algorithms are built to do.
Exactly. Take law, for example.
Yeah.
Law is highly nuanced, obviously, but the foundation of legal work is document review, precedent search, and boilerplate drafting.
Right. Tons and tons of reading.
Yeah, and a context-aware legal model can synthesize 10,000 pages of case law in seconds. It can identify contradictions or format clauses based on really specific state regulations. The cognitive processing power is undeniable, which is why categories like architecture and engineering, life and social sciences, and arts and media also show huge theoretical coverage. They're hovering up in the 0.7 to 0.9 range.
Okay, let's unpack this. Because looking at this massive blue shape stretching toward these specific jobs, it looks like a giant tidal wave specifically targeting desk jobs and knowledge workers. But if this technology is so omnipotent for desk workers, why does it hit an absolute brick wall the moment we look at physical jobs?
Yeah.
Because taking our eyes off that massive blue area on the right side of the circle, the left side is virtually blank.
It is. The blue shape just completely flatlines. It hugs the zero mark right in the center of the circle for categories like agriculture, construction, installation and repair, personal care, and transportation.
So you are looking at a fundamentally different world of work. Here's where it gets really interesting, I think. If you're listening to this while driving a truck or working on a construction site or cutting hair, this chart basically says you are in an AI fortress.
Yes, a total fortress.
The theoretical capability doesn't even reach the point 2 mark for you. But why the massive drop-off? I mean, if an AI can write a flawless appellate brief, why can't it frame a house?
Well, you're touching on a concept in computer science known as Moravec's paradox.
Moravec's paradox.
Yeah, so back in the 1980s, AI researchers, specifically Hans Moravec, discovered something totally counterintuitive. High-level reasoning like playing chess, analyzing financial markets, or writing code requires incredibly little computation.
Wait, really? That seems backwards.
It does, but low-level sensory-motor skills, like just walking across a room, recognizing a human face, or picking up a delicate object, require staggering amounts of computational resources.
So doing high-level calculus is actually easier for a machine than acting like a human toddler.
Astonishingly easier. Because the digital world is discrete. It's structured. A legal contract operates within a closed system of language rules, but the physical world is chaotic, it's continuous, and it's unpredictable. Imagine a robot on a construction site trying to, I don't know, install plumbing. The lighting changes every hour, the ground is uneven, the materials have these slight variations in texture and weight.
Oh, and someone drops a hammer nearby, creating sudden acoustic interference.
Exactly. And a human brain filters all that noise out subconsciously, right? But a robotic system has to process every single microvariable in real time just to figure out where its own arm is.
Wow, just to not fall over.
Yeah, which creates massive latency and requires astronomical compute power. So the cognitive processing power of AI has skyrocketed, driving those huge blue spikes on the right side of the chart. But robotics-like, the physical embodiment of that intelligence in unstructured environments, is lagging decades behind.
That honestly reframes the entire robots are taking our jobs narrative.
Yeah.
Because for the last 50 years, the persistent sci-fi fear was the physical android replacing the factory worker or the mechanic.
Right, the Terminator in a hard hat.
Yeah, but this chart visualizes the exact opposite. The theoretical capability is coming for the spreadsheet, not the hammer. We are basically looking at a complete inversion of the Industrial Revolution.
That's a great way to put it. The Industrial Revolution automated physical labor. The AI revolution is automating cognitive labor.
Okay, so we have this massive blue blueprint of what AI could theoretically do, towering over the knowledge workers and completely ignoring the physical workers. But layered on top of that is the second shape on this chart,
Yeah.
reality check.
The reality check, yes.
Right in the center of the chart, there is a tiny, almost star-shaped red polygon labeled Observed AI Coverage.
And honestly, the sheer scale of the gap between that blue theory and the red reality is the most important data point in this entire analysis.
It is genuinely shocking. It's like looking at the blueprint for a massive 100-story skyscraper. That's the blue area. But when you visit the actual construction site, they've only built a tiny red tool shed.
A tool shed, exactly.
Like, look at those peak categories we just discussed. Computer and math, business and finance, management. They had theoretical capabilities reaching out to point 8 or point 9. But the red observed usage for those exact same fields barely scratches past the point 2 or point 3 lines.
Yeah, and in Office and Admin, the category practically sitting at 1.0, theoretically, the red line of actual observed usage is hovering around 0.3, just a tiny fraction of its potential.
Why is there such a colossal gulf? I mean, the data shows us this massive gap exists, but it begs the question, if the technology is genuinely capable of doing this cognitive work, why aren't businesses actually using it? Is the theoretical capability just totally overblown by tech bros trying to sell enterprise software?
Well, no, the capability isn't a lie, but it exists in a vacuum. Like we said, theoretical models assume perfect conditions. But the red shape observed usage, that has to survive the incredibly messy, friction-filled reality of corporate infrastructure. So we have to look at the actual mechanisms preventing adoption.
Okay, let's get into those mechanisms. What is the biggest roadblock keeping that red shape so small?
The biggest one is the fundamental architectural clash between legacy databases and modern language models.
How so?
Well, let's say you're a major bank or a massive logistics company. Your infrastructure is built on relational databases from the 2000s or 2010s. Those are highly structured, deterministic environments.
Meaning what exactly?
Meaning when you send a query, you need an exact, mathematically perfect retrieval of data.
Right, like a closed, rigid filing cabinet.
Exactly. But modern LLMs, on the other hand, are probabilistic prediction engines. They don't actually retrieve information, they generate it by guessing the most statistically likely next word.
Ah,
So getting a probabilistic engine to interface safely with a deterministic database without breaking the system or, hallucinating someone's financial records is an engineering nightmare. Connecting them requires building massive middle layer architectures.
which takes years
Yeah.
and millions of dollars. Because corporate software migrations are notoriously brutal, even when you're just moving from one deterministic system to another.
Oh,
So introducing a probabilistic wildcard into the mix just makes IT departments freeze up.
they absolutely freeze. And beyond the architecture, you also have to look at the economics of compute power. Because theoretical capability assumes you can just ping an API whenever you want, but look at the token economics of running enterprise-scale AI.
Could you just quickly explain token economics for someone who hasn't looked at the pricing structures?
Sure. So every time you send a prompt to a language model and it generates an answer, it costs processing power, which is measured in tokens. If a developer runs a few queries to test a capability, it costs pennies.
Right.
That scales beautifully in a lab. But if a multinational corporation deploys an autonomous AI agent to process, say, 1 million customer support emails a day, and that agent uses a complex multi-shot prompt chain to evaluate each email,
Suddenly you're burning through server farms.
yes, the cloud compute costs become astronomical.
Huh.
The theoretical capability is there, but the profit margins just evaporate once you scale it to enterprise volumes.
Wow. Okay, so we have database friction and compute costs.
And that leads to the third major friction point: liability and hallucination frameworks. You mentioned earlier how capable AI is at drafting legal documents.
Right. The blue spike for the legal category was massive on the chart.
It was. But imagine a prestigious law firm trying to integrate an LLM. To get the AI to actually do the work effectively, the firm would need to feed it thousands of proprietary, highly confidential client documents.
Oh, wow. Yeah, feeding confidential merger and acquisition data into a third-party cloud model is a fast track to disbarment.
It violates literally every non-disclosure agreement they have.
So what do?
Well, they try to build a local siloed model, but then they run into the hallucination risk. Because if a human paralegal makes a mistake, the firm's quality assurance process usually catches it.
Right.
But if an LLM hallucinates a fabricated legal precedent and a partner submits it to a federal judge, which, by the way, has already happened in real-world cases, their reputational and financial damage is catastrophic. The compliance hurdles just prevent adoption, keeping that red shape incredibly small.
It's like having a Formula One race car. The engine is technically capable of doing 200 miles an hour.
But you are trying to drive it in bumper-to-bumper city gridlock.
Yes. The Ferrari in traffic,
Mhm.
the capability is undeniably under the hood, but the environment, the legacy systems, the compute costs, the legal liabilities, it simply doesn't allow you to get out of first gear.
Exactly. The red shape isn't small because the technology is failing. It's small because human institutions, legal frameworks, and established habits are just incredibly dense, slow-moving structures.
So what does this all mean for the listener if we connect this to the bigger picture? If you work in one of these high blue categories, arts and media, life and social sciences, architecture and engineering, do you panic about the giant blue blueprint that says your job is theoretically automatable? Or do you take comfort in the tiny red tool shed that says no one is actually doing it yet?
Well, you don't panic, but you don't get complacent either. You should look at the space between those two shapes as your personal buffer zone. The chart visually proves that theoretical technological capability does not equal instant human adoption.
So that buffer zone buys you time.
It does. If you are in a high blue category, the data shows that your peers, your competitors, and your industry as a whole are largely paralyzed by those integration friction points we just discussed. They haven't figured out the architecture or the liability yet.
Right, so the sky isn't falling today.
The sky isn't falling, but the weather is changing. The massive gap between the red and blue polygons represents arguably the greatest professional opportunity of this decade, because the space between observed usage and theoretical capability is where innovation happens.
You become the person who figures out how to safely drive the Ferrari in traffic. Like if you're a financial analyst and your firm's observed AI usage is stuck down at 0.1 because they're terrified of data leaks, but the theoretical capability is up at point 0.8.
Right.
You figure out how to deploy a secure, localized model that cuts your data synthesis time in half.
Yes, you leverage the slow adoption rate of your industry to outpace your peers. Because look, that red shape is small now, but the friction points, the compute costs, the database integrations, the legal frameworks, they are actively being solved. The red shape will grow.
So instead of looking at this as a map of obsolescence, it's a map of untapped potential. The blue area isn't necessarily what AI will do instead of you. It's a map of what AI can theoretically do for you, provided you learn to wield it before the rest of your industry catches up.
Exactly. And if you're in one of the low blue categories on the left side of the chart, like construction, agriculture, or personal care, your advantage is entirely different.
Because your skills are tethered to the physical world.
Right. Your buffer zone isn't just about slow corporate adoption. It's protected by the laws of physics and the brutal realities of Moravec's paradox.
It's a really unique kind of job security in this specific technological cycle. So to wrap up today's deep dive, the main takeaway from this single chart is the stark visual divide it presents. On one side, we have the white-collar world overshadowed by a massive blue potential for automation. And on the other side, the blue-collar and physical world remains largely untouched.
And layered over all of it is the reality that actual observed AI usage is currently just a tiny red speck compared to its massive theoretical potential.
It brings us right back to that weather radar. The model shows a hurricane, but right now, outside your window, it's just a drizzle. You have time to prepare, time to adapt, and time to figure out how to capture the rainwater instead of drowning in it.
I love that. And I'd leave you with one final thought to ponder. Right now, that red shape of observed usage is tiny, yet it is already dominating our news cycles, restructuring venture capital markets, and fueling global anxieties.
It feels massive to us, even though the data shows it's just a sliver.
Exactly. So imagine this chart 5 or maybe 10 years from now. Think about the economic shifts we are already feeling from that tiny red center. What happens to our economy, our definitions of human productivity, and our society as a whole on the day that tiny red shape finally expands, snaps into place, and perfectly overlaps that giant blue blueprint.